So in this problem, we have a particle of mass 1 gram and charge 1 microcoulomb moving with a velocity of 4 meter per second is subjected to a uniform electric field of magnitude 300 volt per meter for 10 seconds. Then its final speed cannot be. So let us write down whatever is given in the problem. The charge carried by the particle is 1 microcoulomb, which is 10 raised to minus 6 coulomb. Then the mass is 1 gram, which is 10 raised to minus 3 kilogram. Then it is moving with a velocity of 4 meter per second. So its initial velocity is 4 meter per second. So u is 4 meter per second. And then it is subjected to a uniform electric field of magnitude 300 volt per meter. So this is 300 volt per meter, and for a time of 10 seconds. Then the question is, what cannot be a possible value for the final velocity? Four values are given: 0.5, 4, 3, 6. We have to find that value or values for the final velocity, which cannot be a values for the possible values for the final velocity of this particle. So now let us see how this problem can be done. So you know that the initial velocity is given, then the electric field, magnitude of the electric field is given, then the time for which the electric field was applied on the particle is also given. So the next thing that we can find out from this is the acceleration of the particle, which is equal to QE divided by m, and that is equal to 10 raised to minus 6 into 300 divided by 10 raised to minus 3, and this is equal to this is 0.3 meter per second square. That is the value of the acceleration. Now the thing is that we have two possible cases here. In the first one, the particle's velocity and acceleration, initial velocity and acceleration are in the same direction. That is the first case. The initial velocity and acceleration are in the same direction, or the electric field is acting in a direction which is the same as the direction of motion of the particle. Then it will be accelerated. Suppose the electric field is acting in a direction opposite to the initial direction of motion of the particle will be retarded. It is not mentioned in which direction the electric field is applied. So we have two possible cases. The first one, acceleration positive, and the second one, acceleration negative. It means in the first case, the electric field and the direction of the motion of the particle are the same. Second case, the electric field is acting in a direction opposite to the direction of motion of the particle. So let us discuss the first case when the two are in the same direction. So this is the first case. So we have V equal to U plus AT, which means V equal to U is 4 plus acceleration is 0.3 into time of journey is 10 seconds. So this will be 7 meter per second. So that can be the final velocity of the particle, 7 meter per second. If both are in the same direction, that is, the velocity, initial velocity and acceleration of the particle are in the same direction, the final velocity of the particle will be 7 meter per second. Now let us look at the second case when they are oppositely directed. Again, V equal to U plus AT, but this time acceleration is negative. So V will be equal to 4 minus 0.3 into 10, and this will be 4 minus 3, which is equal to 1 meter per second. So we have a situation where the maximum velocity of the particle or the velocity attained by the particle after 10 seconds can be 7 when the velocity and acceleration are in the same direction, and 1 when they are in the opposite direction. So the velocity of the particle will be lying between 7 and 1. So any value which is above 7 or below 1 cannot be a possible value for the final velocity of the particle. So the maximum value that velocity that this particle can attain is 7, and the minimum that it can attain is 1. Anything below 1 or above 7 cannot be a possible value final velocity for the velocity of the particle after 10 seconds, and that means there is only one option here, which is option A, 0.5, and that has to be our correct answer.